Okay, so this is 12102 Team Run Problem 10. And in this question, Edwin and 2019 people are playing hot potato. And the potato starts at Edwin, and at each turn, it's passed to the either right or left with probability 1/2. And we want to find the expected distance from the last person to Edwin. So suppose there's an arbitrary person P on the circle, and we're going to try to show that the probability that P is the last person to receive the hot potato is the same for regardless of where P is on the circle, except for when P is Edwin. And obviously in this case, the probability Edwin is the last person to receive the potato is 0 since he starts with the potato. So suppose there's a person P on just labeled here, and we're going to label Edwin 0. And we're going to label the other 2018 people besides Edwin and P like this. So we're going to label 1, 2, all the way around. And here we're going to label -1, -2, all the way around. So at some point, the person P on the person on P's left is going to be labeled D, where D is some positive integer. And since there's 2019 people that are labeled, the person to the right of P is going to be labeled D minus 2018. Okay, so now we note that before the potato gets to person P, it has to reach either person D or 2018 first, because reaching person P will require the potato to pass through all the people between P and Edwin in either direction. Okay, so now we consider a number line. And suppose a marker that starts at 0. And at each point in time, it goes either to the right or the left with probability 1/2. And so somewhere along the number line, we're going to have 2018. And to the right, to the left of 0, we're going to have -1 and all the numbers in between. So we're going to let P be the probability that the marker will get to 2018 before it gets to -1. And we know that after an infinite number of turns, it's going to hit either of these two at some point. So, and we're going to note that P is a constant since it's defined in this constant scenario. And also note that when we shift all the numbers to the right or to the left by an arbitrary number, say K, the probability will remain the same. So like KB here, the probability that the marker will get to 2018 before it gets to K minus 1 will be the same regardless of K. And also note that we can also do reflections. So say K is right here. Then the probability that the marker will get to K minus 2018 before it gets to K plus 1 will be the same regardless of K. And in all three of these scenarios, the probability will be P. Now consider what happens when the potato gets to either D or D minus 2018. We already know that the potato is guaranteed to get to either of these two people before it gets to P. So let the probability gets to D be S, and let the probability gets to D minus 2018 first be 1 minus S. So the potato will get to either of these two people. And we're letting S be the probability that it gets to D before it gets to D minus 2018. And then 1 minus S is the reverse scenario. Okay, so consider a number line where the marker starts on person D. So we're considering this what happens after the marker has already gone to person D. And we're going to have person P to the right of D. And P will be represented, even though P isn't labeled, it's going to, on this number line, it will be represented by D plus 1 since person P is immediately to the right of D. And at some point here, we're going to have D minus 2018. And we're going to note that the probability that P is the last person to receive the hot potato, given that D receives the potato before D minus 2018, is P. Because in order for P to be the last person, after the potato has reached person D, it has to loop all the way back around to person D minus 2018 before going this direction. It can go back and forth, but it has to hit this person before it gets to person P in order for P to be the last person. And this is the scenario we have here, where the marker starts on person D, and it has to go all the way to D minus 2018 before it gets to person P. And we know that this happens with constant probability P. And now we consider the scenario where it gets to person D minus 2018 first. And now we have D minus 2018. This is where the marker starts. But this time person P is on the left of them. And so we have person P here. And even though it's not labeled, we have P denoted by D minus 2019. So note that it's different from this scenario where P is labeled D plus 1. And we're going to have person D all the way over here. And similarly, the probability that P is the last person given that D minus 2018 receives the potato before D will be P, which is the same as this scenario. Because we want the potato to go all the way over here before it goes to person P. And so this also happens with probability P. Okay, so now we note that since the potato is guaranteed to reach either of these two people, then now we can calculate the probability that P is the last person to receive the potato. So the probability that D receives the potato first is S, and then the probability that P is the last person to receive it given this is P. So we have S times P for this scenario. And for the opposite, when D minus 2018 receives it first, we have plus 1 minus S times P. Sorry. And this sum is obviously equal to P. Okay, however, note that since P is a constant, since we defined it based on a constant scenario, that the probability P will be the same for all 2019 people along the circle. So, and since the probability Edwin receives the potato first is 0, since he's the first person to receive the potato, we have 2019 P plus 0 equals 1, since the total probability of each individual person being the last person to receive the potato being 1. And now we get P equals 1 over 2019. And now we know that this is the probability for every single person except for Edwin. Okay, so now we can just calculate the expected distance. So since the probability is the same, we have 1 over 2019. And now we just sum over the distances. So for all the people along here, we have 1 plus 2 plus all the way to the person across from Edwin. He'll be a distance 1010. 1010. And after that, the distance will start going back down since it's getting closer to Edwin. So we'll have 1009 all the way back down to 1. And we note that this is the sum of two triangular numbers. So times 1/2. Then this will be 1010 times 1011 plus 1009 times 1010. And this just equals 1010 squared over 2019. And now since we note that this already fits the form given, we have A equals 1010 and B equals 2019. And so now we get A plus B equals 3029. And that's the correct answer.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.